Hi everyone, I'm Andrew from Omni Intelligence. Today we'll be looking at SIP trunks, and how they are used to deliver calls to your contact center. I have put together this tutorial to support those who require performance testing and/or monitoring of a voice over IP or VoIP system such as IVRs using Omni Intelligence. Before we go there, let's quickly consider how SIP actually works. Suppose we have a caller, Alice, who wishes to speak with a receiver, Bob, via a SIP server. SIP carries VoIP traffic over UDP on port 5060. To establish a call, first Alice's device will send a SIP invite signal over the SIP trunk, which then passes the invite signal over to Bob's IP. Once Bob picks up the call, his device sends the 200 OK signal back to the SIP server, OK meaning to accept the invitation, and the code 200 meaning the action was completed successfully. Likewise, the server passes this signal over to Alice. Once her device receives this signal, it will respond with an acknowledgement signal to indicate to Bob that the 200 OK was received. This will enable the call to be established, allowing Alice and Bob to communicate through Audio Real-Time Transport Protocol, or RTP, which handles the delivery of audio data packets bidirectionally. At the end of the call, a similar process occurs, but instead of an invite signal, a buy signal will instead be sent. Alright, so that's SIP in a nutshell. Now let's break this down a notch. Okay, so what does Alice need to send as part of an invite signal to initiate a call with Bob? Firstly, we'll need Alice's phone number so that Bob knows who the call came from, as well as Bob's number so the SIP server knows who to forward the invite signal to. Her local SIP port is also required so that when the response is sent, the SIP server knows which port Alice's soft phone is listening on. So that's where SIP responses are sent to. But where does audio RTP data go? For that, we'll need Alice's local audio port to receive audio data captured from Bob's mic. Another thing we need is the SIP server domain. So, quick side note, I'd like to mention that the SIP domain is not the company's domain and is also not your PC's DNS. This is a common misconception. So a specific name is allocated as part of the SIP server configuration, and depending on the type of server, you may even have multiple domain names for multiple SIP trunks. To find out your VoIP domain name, you'll need to check with your company's voice architect or SIP server if you have access to it, that is. Anyway, another important thing to note is that audio is encoded using a codec before it is sent. So this is to conserve on bandwidth. There are a lot of different possible codecs. So as part of the invite, Alice will also need to send the codecs her soft phone supports. This is to check for compatibility. For example, depending on Alice's encoding codec, which is say G729, Bob may not give an OK response, to which the audio will be encoded using the default codec G711 instead. Another important thing is the audio chunk size, which determines the amount of data to be sent through each RTP packet. For calls, this parameter will typically be 10 or 20 milliseconds of audio per packet. So before Alice and Bob can begin talking, they will need to establish a common codec and audio chunk size. In addition, they need to agree on which UDP ports the audio will be sent between the participants. Audio is sent using another protocol, which is not SIP. This protocol is called Real-Time Protocol, or RTP. During the invite ACK negotiation that is done on SIP, Alice will advertise its own RTP port for the audio that Bob captures from his microphone, while Bob will advertise its own RTP port so he can hear Alice. These ports are normally taken at random from a range of UDP ports between 16384 and 32767. This range is standard for RTP. The whole entire range will need to be allowed through the firewall if you have one, but we'll get to this shortly. They will also require an authorization username and password if authentication is enabled on the SIP server. Once that is complete, Alice and Bob can begin sending and receiving audio packets to each other via the port. The reason we might have multiple ports is Alice can have multiple calls at the same time. For example, Alice might be talking to Bob while having another call on hold with somebody else. So this is a very typical scenario in contact centers. Now that we know what needs to be done to establish a call between Alice and Bob in SIP, let's talk about what a SIP trunk is. The SIP trunk is basically a configuration that is done on both the SIP server and the soft phone that allows to make SIP calls. This configuration contains the SIP domain, which I've already discussed a few seconds ago, but I'll just say it again. The SIP domain name is configured inside the SIP server and is not the website URL or the PC DNS. It can be an IP address though. A proxy is basically where the SIP packets are sent to. The SIP server is normally sitting behind the proxy and is not accessible directly. In many cases, however, the SIP proxy and SIP server is one and the same. In your case, you will need to check if the voice system has a proxy with the voice architect, if you don't have that information, that is. If authentication is enabled in the SIP server, the trunk will also need these credentials as well. In Omni Intelligence, we also have line ID as part of the SIP trunking configuration. This is because Omni Intelligence script will act as Alice, and the line ID would be Alice's phone number. So now that we've laid out the cogs and gears of SIP trunking, let's talk about what actually happens with the trunk. Before an invite signal is sent, the trunk appends a header which encloses the from URI, which is the line ID, as well as the to URI, which is the destination. These are SIP URIs, and they are built the way you see on screen. So you have SIP, username or phone number, at SIP domain. These URIs will be built by Omni Intelligence automatically, taking the phone numbers and domain name from the SIP trunking configuration and the script. The Omni Intelligence script sends this header, along with other details we looked at previously, to the proxy, but if one is not present, it instead gets sent directly to the server domain. Basically, this is a summary that we need to know in order to perform a load test or run a monitoring scenario in Omni Intelligence. So now, let's have a look at typical problems that may arise here. For this next part, I'd like to make a quick disclaimer. The issues I'm going to talk about are related to scenarios where the customers are downloading and installing the testing components locally, because if a testing is launched via PSTN using our cloud, there will be no issues as we ensure that everything is configured properly. A lot of the time, we get calls from our clients asking, "Why are my calls timing out?" or "Why is there no audio?" When a call fails to establish and times out or has audio issues, there are a number of reasons why this may be the case. Both callers will be accessing the SIP server through their routers, so it's important to check if both the caller and the receiver can route to the SIP server without being blocked by the firewall. When it comes to stress testing, your load generator will typically be networking through a series of routers over the Ethernet before reaching your SIP server, which will run your IVR. Each step in which a packet can be passed from one of your network entities to the next is known as a hop. What this means is that if the call times out, we can check the logs on each hop to identify which router is the problem child, which router has a firewall, or some other issue which is blocking the packets. It's also important to note that the SIP server itself may also have a firewall. Logs should be checked on the way out for each hop of the invite step, as well as on the way back for the 200 OK response. If the call is established, but no audio is heard, repeat the same process of checking the logs, but for audio RTP instead. Another thing to keep in mind is the access control lists, also referred to as ACLs. Most SIP servers have a list of IP addresses that the SIP server is allowed to receive calls from. When it receives a call from an IP on the list, it will allow the call to proceed. But if a SIP server receives a call from an IP which is not on its ACL, there are two possible outcomes. 1. The SIP server gives no reply and times out. 2. We get some error response from the server, typically 403 forbidden. Another reason this kind of error response may show up is due to bad credentials in the server configuration. One example being an incorrect password. So how do we go about figuring out whether a call is failing due to some kind of error, or whether it's timing out? One thing we can do, and I've mentioned this before, is to check out the logs. So I'm going to log into my Omni Intelligence account just to demonstrate. Right, let's open up our scenario by clicking on Edit. And we can go to the Executions tab here to view every single session that we've run. So I've run some debug sessions beforehand. Let's click on one of them. And what we can do is scroll and read through the logs. So what this can do is help you identify what's throwing a monkey wrench in the works. And you can use this kind of information to figure out what needs to be done, whether it's checking out the networking, and by this I mean the firewalls and routers, or whether you need to check the ACL or the credentials as well. So hopefully this can help you identify what's causing issues with your calls. This final slide is a quick summary of what we've gone over and how to troubleshoot these type of issues. I'll say it again, here we're talking about scenarios where the customers are downloading and installing the testing components locally, on-premise, and if a testing is launched using the Omni Intelligence Cloud, you won't face these issues I've talked about. However, once the networking has been configured, as I've described in this video, you should be able to make calls with Omni Intelligence inside of your network. If you still have any issues, you can contact our support by submitting a form using the link on screen. Anyway, that's all for now. I hope you got a thing or two out of this video, and I'll see you all next time.